So good evening, guys, and welcome from Cheenta Statistics and Analytics Department. And we are live today. So there's certain exciting updates in Cheenta regarding the few facts that our students will enjoy. And according to we have started this, all know like we are weekly mock tests for the platinum students. So it will be a short mock test, but at least there'll be a mock test instead of the monthly test. We will be starting short 6 to 7 problems mock test a week, and it's on the roll actually. I mean, we have entered in the whole procedure of Cheenta, our working. So that's the first update. The second update, the crash courses are starting according to the corresponding topic from October. You can actually see the link is given in the description below, and though for those who are actually enrolled in platinum courses, for them it will be really free enroll and do any of those class according to their own time and stuff. So we are constantly upgrading our services for the preparation gets to the next level. And now also another update is that this class is being transformed from 1 hour class to 1.5 hours class. Stuff based on our students proposal to make it a more like problems. Let's to celebrate problem solving more. Why we have done this, and I think it will be helpful for the students. So let's get started, guys, and without further ado. Till now, we have been doing, we are in the continuous distributions part. And last day, as I think Nikhil was there, so Nikhil suggested something really interesting. And it's okay. So I will, in terms of problems, proof of it, okay? So that is the main aim of today, and also solving stuff. So it's kind of a theoretical part and a real problem solving part, because both of them can come in your like exam. Like in the exam means like theory important to understand the whole stuff, the proof of it, and the problem solving understandable because this prior problems always come in JAM and ISI both. Let's start it, and without wasting our time, just let me ping in the page. Okay. Let's see what the problem is. The problem asks you that whether, so we have all studied cumulative distribution functions. So problem to ask you, this is a very common question to test whether a function is CDF or not. Okay, whether a function is CDF or not. So the question revolves around the fact that prove that, like find whether fx is equal to e to the power minus e to the power minus x. Is this a CDF? That's the first question. So is this a, so we have to first criteria of the CDF and prove it. So what do you think, guys? What are the criteria we need to check for a CDF, guys? Bolo. What are criterias? What are the criterias? Bolo. Anyone, guys?
It's approaching from it. One.
Okay, so the first criteria telling us is limit extends to infinity f equal to 1. That's the first criteria. Let's check it out. So it's limit problem of calculus. So power minus e to the power minus x equal to, since e to the is a continuous, e to the power minus limit of tends to infinity minus x. So limit x tends to infinity e to the power minus x is what, guys? This one is what? Bolo, bolo, bolo. What will be limit x tends to infinity to the power minus x?
0.
So perfect. So we have got that e to the power minus 0, so which is equal to 1. Perfect. So it's perfectly matching. What other criteria we need to check, guys? What other criteria we need to check? Bolo quickly.
Minus Zero.
Okay, perfect. So we should check also either x limit x tends to infinity minus infinity x is equal to 0. Let's check it out. Limit x tends to minus infinity e to the power minus e to the power x. So limit x, sorry, e to the power minus limit x tends to infinity minus infinity e to the power minus x. It will be what, guys? E to the power minus x tends to infinity to the power minus x
Infinity.
minus infinity, which is equal to 0. Perfect. Perfect. So super good, super good. So this is actually also holding. So does always limit fx 1 and fx like x tends to infinity fx equal to 1 x tends to infinity fx equal to minus infinity fx is equal to 0. Does it always satisfy that it's a like it's a CDF or not? No. There are other properties. There are other properties. What are other properties? Let's check it out.
There's something disturbing side.
There's some disturbance from my side. All of it are
It's still there.
still there. Okay. I can still hear all of you. Okay.
Yes, and all.
Okay. So right continuity. Continuity. Right continuity. What you need to check is that limit x tends to, let's say, c f of x is equal to. But here you can easily understand that fx is continuous. Fx is continuous, okay? Because it's made up of continuous. It's a composition of continuous functions. Compositions of continuous functions are continuous. Is continuous. So it's already true. Any other properties you need to check, guys?
Beyond.
No one can hear me.
So there are noises at the side.
Again and again, noises on my side.
Loud noises.
Oops. Let me check. Hmm. Exactly. It's facing. क्या करूं? My audio is inconsistent. Okay, yeah. People. I don't know if like it's the same thing on the wave actually. Then I have to bring my laptop. Just give me a minute. Just any other people. I don't know if like thing on the wave. Hello, hello. Network getting I am back now. So just some issues maintained. So I will just it because I other tabs and stuff. So yeah. Sorry for such a thank you for your patience. Hey guys, hello guys, welcome back, and I hope the noise is fine now. So chalo, let's start again. So fine now, guys. I can hear me. Huh? Just give me a thumbs up in the comment box. And thank you guys for being waiting for me for a long time. If you're here on live still, so let's get started. Yeah, fine, Dishika and others. Everything fine. I hope. Suryangsi, Shupro. Okay, perfect. Thank you guys. So let's get. We were here in this. We are here in this of uh, right there on the fact. See, like if fx is right, so fx is continuous, so hence right continuity is just a byproduct of that. Okay, so that's kind of really a byproduct of that. Let's check out. Let's check something else out. What are other properties and others? Can you just tell me what other properties we need to check? Decreasing function, perfect. Non and again, is it fine? No, it is not fine at all. Okay, in between it net issue or something like that. Like this, I don't know. Like, and it's not fine. Rain, I am. I don't know what to do. Anyways, so let's try it out. Whatever we can do. The best I can do. So coming not clear. Okay, so okay, let me if what we can do. I think then there's some net issues and stuff like that. So that's why I think. Oh God, this is a bit weird. Oh, just let me try out. I think the issue. Um. So let Yeah, I hope it's better now. I don't know. Like, I have just changed the connection. I don't know. This is the best. I don't know. Anyways, let's try it out. So fx is continuous, and Nikhil was telling me in the live chat that fx need to be between 0 and 1. Okay. So fx need to be between 0 and 1. So if we prove that fx is increasing and fx as x tends to infinity it's 1 and x tends to minus infinity and minus infinity it's 0, so automatically we prove that fx is kind of between 0 and 1. Okay, so that's what we can show. That's what we have, like that we can actually show. I hope everything is clear now, guys. Otherwise I will cancel the class. I mean, there's no. Okay, let's see if it's like help b is fine. So in the future, so essentially what we're having, that fx is less than equal to 1 and greater than equal to 0. This is another thing. Another property we need to check is that fx is increasing or non-decreasing rather. Okay, and let's check it out, guys, whether this is true or not. So fx is equal to e to the power minus e to the power minus x. So this was the function, right? Yes, e to the power minus of e to the power minus x, and let's see. So e to the power minus x is what? Decreasing, right? C to the power minus x is decreasing, and minus of e to the power x is what? Is therefore increasing. Negative of a decreasing function is increasing function, and e to the power, therefore my e to the power x is an increasing function. So ये दोनों मिला के composition of this two, you will get e to the power minus of e to the power minus x is is increasing. Okay, so e to the power x is increasing function, e to the power minus of e to the power minus x is increasing function. So therefore what we get, e to the power, like, if since this is increasing function, so this is greater than this if x is greater than y, and since e to the power x is an increasing function, we take this to the power this is greater than e to the power minus this to the minus this. So x is greater than y, therefore this is greater than this, so we get that f of x is greater than f of y. So therefore we get that fx is an increasing function now. So this is what we have got now, right? This is what we have got now. Perfect. I hope everything is clear now. So we checked all the properties of distribution function. Okay? Sure. So what we need to show about the increasing function part, guys? We need to show that if x is greater than y, e to the power, like, f of x is greater than f of y. This is the increasing function definition, right? That means we have to show what? We have to show that e to the power minus e to the power minus x is greater than e to the power minus e to the power minus y. This is what we have to show. And understand this very carefully, that what we are showing now, e to the power minus x is decreasing function. We know that if x is greater than y, e to the power minus x is decreasing, so this will be opposite sign. Minus, therefore, will be just opposite, just reversing the sign. Now e to the power x is increasing, so if a is greater than b, e to the power a is greater than e to the power b. So we put a as this and b as this. So we get e to the power minus of e to the power minus x is greater than e to the power of minus of e to the power minus y. So therefore we get that f of x is greater than f of y. So therefore we get that if x is greater than y, f of x is greater than f of y, and that is this is a distribution function in non-decreasing part. In fact, we have proved it's increasing. So we have found out all the properties. Number one property was fx is between like 0 and 1, but we will show it in a different manner. We show that f of x, f of infinity is 1 and f of minus infinity is 0. F of minus infinity is 0. Okay. What we have shown else? Fx is increasing over here, non-decreasing rather. Also, this three implies together that what Nikhil was telling in the live, that fx is between 1 and 0. Okay, and what else we have now? We have shown that fx is right continuous. So these are the main properties we need to show. If it's right continuous, here we have shown that fx is continuous only. So that's it, guys. Okay, everything clear, guys? Everything clear? It's not continuous, Ritaja, it's right continuous. Here it's continuous is a bypart of it, like it's something extra we have got, and that's why it's a continuous random variable. Okay, as we have defined before in our classes, Monday classes. Okay, guys, everything clear now? Everything clear? All of you understood that fx is a if it's fx is a distribution function, guys. Yeah, and thanks for bearing with this whole technical issue. I don't know everything, like due to this rain in Kolkata. I think there are certain issues with my network, with the LAN wire actually, or I mean the net connection, net broadband service provider. So I'm really sorry for the issues the live people and the your my students have got. So I mean, this is something I don't have in my mind. I mean, in my hands. So I'm really grateful to you for cooperating with me. Okay. So, but what was the problem? We have shown that fx is equal to e to the power minus e to the power minus x is a CDF. This is what we have shown. Okay. Now, the question is something else. The question is that if x is a random variable corresponding to this CDF, random variable corresponding to this CDF, fx. Okay. If x is a random variable corresponding to this CDF, you have to prove, rather, you have to find the expectation of f of x. F is a CDF. So for this, what we need to understand, for this there are two aspects of it. So we'll learn today some ideas to tackle this. So one is the law of, one will apply the law of unconscious statistician. This is called Lotus lovingly. The next is the universality of uniform distribution. Okay, how every distribution is connected to the uniform distribution and how we can use it to simulate other distributions actually. And with this will come we will learn about the ideas of functions of random variable. Okay, one dimensional random variable. So let's understand this. So essentially what we mean, so x is a random variable, so x is a function from the sample space to R. Now understand, consider f is what? F is taking values from R to 0 comma 1. Okay, this is like distribution function over here. You can generalize to any f, let's say g. G is a function from G R to R. Okay. So what we're trying to understand, what is g of x then? G of x is therefore what? G of x is therefore. So here what do we mean by g of x? Here we mean by e to the power minus capital X. So understand, this is taking value from the sample space to the real number line, in fact to 0 comma 1. So it is actually a valid random variable. So when something is a valid random variable, what we need to find? We need to find its PMF or PDF. It's a continuous random variable, PDF. Uske aage CDF, then uske PDF, and then uske moments, right? And that exactly we are looking for. So the question is that given any function from real to real and a random variable x from sigma, like from the sample space to R, we are considering and we are forming a new random variable g of capital X, which is a function from the sample space to R. So how will this behave if we know the behavior of x? If we know that this x has, if we know that this x has what? Then or CDFF, then how will the g of x behave like? So that's the main question. Okay, that's the main question. So this is the main question we are looking forward to. But today we will do a special case. So there is a method called what? Called Jackie. It's a method called the method of CDFs. So this will be really, really helpful to find, like, you know the information about X, you know the function G. So this will help you to find the distribution of function of the distribution, the CDF. Because CDF is the main, from there you can actually derive and differentiate it to get the like, not only differentiate, to get the PDF actually. So you will get to know the CDF from here actually. Okay. So this is the method of CDFs. So how do we do it? So we do it like this. So we find, let's call it Y. So we find probability, like f of y, that is the CDF of this random variable. Probability y less than equal to y. This means this is probability g of x less than equal to small y, right? So probability g of x less than equal to small y. And but here, see one thing here, this is the main idea. So we will use the property that property of some, this is something we will learn in the next Monday class, okay? How to attack it generally. But today our main focus is if this gx is equal to the f of x, that is a CDF of x, what will then happen? Okay, so let's try it out then. So what we will do now, we have understood here that let's take f of x to be y. So we have got f of y is probability y less than equal to y, which we have got probability f of capital X less than equal to small y. Now understand this, something interesting. What is f? Is a CDF, right? So f is here in this case it's continuous and it's increasing, right? So there's a result in real analysis in calculus that if a function is continuous and increasing, then if a function is continuous and increasing, then it is bijective, it's invertible. So you must revise your knowledge of bijective from your pre-calculus classes in 11, 12 from books. So it's a bijective. So f inverse exists. So what is f inverse? F inverse is such a function such that f inverse of small f, capital Fx is x, and f of f inverse x is x. So these are the two things that, these are the two properties of inverse function. So here it's bijective, so f inverse exists. So how can it help over here? How can it help over here? Let's check it out. How can it help over here? This will help us to find, actually, to find the probability in terms of the CDF of x. That will be the help of f inverse. Let's check it out. How? So we do f inverse of x is less than equal to f of y. So we'll get probability, it's a x over here. Probability f inverse f of y, this result will get its x less than equal to f of y, capital F of y. Okay. And now understand that therefore it's what? This is therefore capital of f of, sorry, I think it's inverse, f inverse on both sides. F inverse on both sides, sorry. We did f inverse on both sides. So capital F of f inverse of, like this is what? This is, if this is C, then this is f of C, because f is the CDF of this x. And here C is f inverse of y. So it's f of f inverse of y, which is equal to y. All of you understood this, guys?
So
Yeah, bolo.
first we took g of x is y and then we took f of x is equal to y.
Yeah, g of x is the general function I was taking, but here f of x is what we are looking forward to, right? That was the question. Find the expectation of f of x. Gx is a general function. Here we took f is, which is a distribution function in place of a special case of gx.
Okay.
Did you understand?
Yes.
All of you understood this, guys? Any doubts? Any doubts, guys? All of you understood this?
Second last step.
Yeah, bolo. Which portion? Bolo. Second last step means
So when we
this
substitute
one, this one, this one.
when we substituted F inverse Y as C.
This one, okay. So this is what we have defined as C. So now what? See, this is what? This is probability x less than equal to C. If probability x less than equal to C, that is what? That is exactly capital F is the distribution function of x. So f of x is what? Probability x less than equal to x. So here it's f of C. Now C is what? F inverse of y. So we put it over here. Did you understand?
This would be fxc, right?
Fx. Yeah, it's actually fxc. Yeah, you're right. This is f of ic. You're right. This is all these f's are fx of c.
And how is it equal to y then?
Oh, this is just a real number. F inverse of fx is, or f of f inverse x is x. So if you put x in place of y in place of x, you get y. It's a real number, just a real number. Nothing to do with a random variable. Y is a real number here. This is the random variable. So this random variable is replaced in terms of x. So everything is in now terms of x. Only rest is this x is a random variable. So here this x is a random variable. But all these right hand sides are real numbers. Did you understand? Sneha,
Yes.
all of you understood this? Aishwarya, Madhav, Mansi. I know today is a bit of like a bit of different scenario because of the net connection. I'm really apologizing for that. I hope everything is clear. Sritaja, Suryanshi, Shuprabhu, Tishika, Proma, Priyansh, Pratiksha, Polami, Mansi, Madhav, Aishwarya. Okay, thank you, Madhav. Okay, so perfect. So we get that. So we get what? We get that f of x, f of y of small y is equal to y. Okay. So, and also y is between 1 and 0. Okay. Why? Because fx is a fx. Why? Because f, capital F, like this y is capital F of x. Capital F is a CDF, so it's taking value. Y is taking values in 1 and 0 only. The range of y is 1 and 0 only. That's why the small y is between 1 and 0 only. So what do we get over here? From here, we get that if you do the PDF between on the support, this is where it's 1, right? Between 1 and 0. And this is the density of what? This is the density of uniform distribution. So this is called the universality of uniform. Okay, it's called the universality of uniform. So here, since e to the power minus x follows the uniform 0, 1. So therefore, expectation, if I call this w, then expectation of w will be half, and variance you can find it out easily. So this was the main idea. Not only this, in exam they will give you in terms of normal, they will give you in terms of various other things. Okay, so they will give you like a random function, but you will actually it will be a CDF, so you have to use that property. This is a really important result. Okay, and people in IIT and ISI, all this, like the exams, the questions, in fact it's in gate statistics also, people use this very often. Okay, this is a very important result in random variables part. Okay, so all of you understood this result, guys. It's a very important problem solving strategy actually. All of you understood this result. Any doubts? Sriteja, are you happy with this problem solving, or you want more? Yep, everything is fine, guys. So can I move on to the next problem? Okay, so we have got this. I got the idea of this problem. Okay, so let's move on to the next problem. and let's check it out. Let's check it out. What else is there in my plate? Just give me a minute. Okay, so I have this problem on my plate. Yeah, you're right, Nikhil. The variance is 1 by 12. You're totally right. You're totally right. Thank you. So because it's a uniform one. So you can easily find out now the aspects of all the uniform distributions. That's the basic idea. So okay, so that's the basic idea. So let's check out the other next problem I have in my mind. Okay. The problem is this. Let me just take a screenshot of this. Okay, so the problem is this. The problem is that the problem asks that athletes complete one at a time high jump. Okay. So let's understand the problem. So athletes complete, so it's on Olympic time. So let's so I thought of giving you this problem. So athletes compete one at a time at the high jump, and let xj be the how high the jth jumper jumped. Okay. You understand? Athletes compete one at a time at the high jump. Let xj be the how high the jth jumper jumps with x1, x2, all of them following a continuous distribution, right? This makes a lot of sense. This analogy and this distribution makes a lot of sense. And we say that jth jumper sets a record if xj is greater than all of the xj minus 1, xj minus 2, x1. Okay, this is the question. Okay, so like this is a description of the problem. So let's see the question. The first question is this: is the event, this is the first question we should ask. Is the event the 110th jumper sets a record of independent of the event 111th jumper sets a record? You understand? We are asking the question that is the event, you understand, event, because event is something that of which probability we calculate. The question is whether the event 110 jumpers sets a record independent of the event that the 111 jumpers sets a record. What do you think? Let's think about it. Let's think about it logically. What do you think? What do you think, guys? Sneha thinks yes. Who other thinks yes? Just raise your hand. The question is this following, understand. So xj, so what is the mathematical way of justifying this, guys? Can you just tell me? What is the mathematical way of justifying this? So this is something really interesting. There's another property. This is something called symmetry. This is very, very important. Okay, this is something called symmetry of the IIT random variables. This is very, it's beautifully there in Blitzstein. So this is like one of the most important property and the most beautiful property that comes in exam of IIT and ISI both. But this is one of the really interesting property. One of the examples is this. One such examples of such like independent, like the symmetry of this is called the symmetry. It's a problem solving strategy. One problem solving strategy that I told today is universality of uniform. Another problem solving strategy I'm going to tell you today is the symmetry of the IID. Symmetry of IIDs. This is a really important problem solving step. What is this problem solving? It's told that actually the one example is this, that if X and Y are IID something, then probability X greater than Y is equal to probability Y greater than X. The idea is that they're interchangeable. They are interchangeable. The random variables are interchangeable. Okay, so this is the basic idea, and we will use this property. This is really important understanding. Okay, this is really important understanding. So did you understand this? The idea of interchangeability. This is really important, guys, to make, like, it's a very important property actually. So if X and Y are IID, then X. So what is the mathematical form of interchangeability? Can someone tell me? What is the mathematical form of interchangeability? Can anyone tell me? What is the mathematical form of interchangeability of random variables? Any ideas, guys? It's called the symmetry of IID random variables. What is the mathematical format? What is the mathematical way of doing that? Okay, let me tell you. So this is something you need to learn, and it's a very interesting problem solving aspect. So, but let's understand this event first. Let's understand this event first. We'll like learn via this. Okay. So what we get? So we have to see whether the jth jumper sets a record is different from any other kth jumper sets a record. That's the main question. Whether jth jumper sets a record, what is the mathematical format of telling that the jth jumper sets a record? Can someone tell me? If x1, x2, xn, all of these things are there, what is the meaning, mathematical meaning, that this jumper sets a record? It's already there in the like problem, actually given in the problem. Can you tell me? It's very easy, guys. It's already there in the problem statement.
Sir, x suffix j is greater than all the x's.
Exactly. So the event is this, that xj is greater than x1, x2, dot dot xj minus 1. This is the event, and we find the probability of this. Okay, so this is the event. This is event A. What is the meaning? Yeah, bolo.
I think the 111 jumper will set a record only when xj plus 1 is greater than x.
Okay, so let's understand the meaning. So let's write the other case, that when 111 jumper sets a record. This means this. Okay, so this doesn't violate this. Like B doesn't violate A and A doesn't violate B, right? B doesn't violate A and A doesn't violate B. Right, guys? D doesn't violate B. B doesn't violate A and A doesn't violate B. Right, guys? Did you understand this aspect, guys? Yeah. So how can you say they are the dependent or independent from each other? So we have to now mathematically and probabilistically tell that, right, guys? So how we can mathematically and probabilistically model this aspect, and that is what we will understand from here. How do we model this aspect? Okay. So we need to check what? We need to check that. We need to check what? We need to check this. That probability of A intersection B, is it equal to probability of A into probability of B? That is, we need to ask ourselves whether this is true or not. Okay. So we need to ask that probability. So what is A intersection B? A intersection B means that 111% is also set jumper record and 110% also set jumper record. So it's x11 greater than x110 greater than all the other ones, x111, x12, x110. 9. This is A intersection B. That means the set A intersection set B. That means the 111% also sets a record, the 110th% also sets a record. This is the basic idea. 111 jumper sets a record, 110 jumper, that's intersection. So intersection means both of them sets a record. That means x11 greater than x10 greater than x1, like all of them. Okay, this is the A intersection. All of you understood this, guys? This is very easy.
Or in the sample space of A in the last slide.
Here? Oh, here.
Yes, sir. Like 110th jumper it has the maximum, right?
1 second, it's loading. Something. Just give me a minute. Yeah, bolo.
Yeah, this 110th jumper has a maximum jump.
Yeah,
So we'll
see, it's
include 111.
no, see, it's a record if x is greater than all the previous ones, not the after ones. X is a yeah, not the after ones. Okay, so it's an infinite sequence, sort of. You understand? So there is no after something. So it's like people keep on coming and jumping. It's someone sets a record if that person is greater than all the previous one. That's it. Okay, that's the meaning of this statement. Did you understand, Tishika?
Yes.
Perfect. So Shuprabhu, did you understand?
Yes, sir.
Good. I hope all of you are understanding, guys. Okay, so let's try to solve this problem, whether this is independent or not. Okay. So we need to find this probability. So how do you find it? So we need to now use the property of exchangeability of, like, this symmetry of random variables. Okay, it's a symmetry of random variables. Let's check it out. Let's check it out. How to do it? How do we can do this? Let's say, understand this very carefully. Okay. So what can happen? Let's see this. So understand the exchangeability of random variables. What is the symmetry? What is the symmetry over here? The idea is that all these numbers, all these 109 numbers are here now. All the 109 jumps over here, these are all equally likely. I mean, among themselves. Okay, understand this. These are all equally likely among themselves. So what do we mean by that? What do we mean by that? The idea is that I will tell you. So let's define something. It's a hard problem, okay? So you need to be focused well. So have all of you heard about the indicator random variable, guys? Indicator random variable. The indicator random variable is what? Indicator random variable is I of A is random variable is 1 if event A happens, 0 if event A otherwise. Okay. So expectation of I of A kya hoga then? It will be what? It will be I into 1 into probability event A happens plus 0 into probability event A doesn't happen, A complement. So it's actually equal to probability of A. This is also a very important result, and we will use this result somehow here. Okay. But we'll use the equally likely case, the symmetry of the random variables. So instead of like thinking, bolo.
When do we use indicator random variables?
We use indicator random variables. There is no when, okay? There is no when. It's like indicator random variable is actually telling that event A happens in this, like it's like telling, it's like, you know, it's like marking 1 and 0 for some event, whether it's happening or not. That's it. Like it's like problem solving strategy. Okay, it's like a mathematical way of thinking. It's like not. It's like it's a proving strategy. Okay, it's not like when do we use it. It's like you can use it always. There's no like thing like when. There is no thing like when to use integer random variables. There's nothing to like think about that. It's all about it's a problem. So it's a mathematical way of writing that, and this is only understandable when you like if you gain experience. That's it. Like it's just when you want to mark one certain event and leave the rest of the others. That's it. And in fact, you can see that indicator random variable is actually a Bernoulli random variable with probability A. See, I will happen with probability A, one will happen with probability A only. So it's a Bernoulli random variable with probability A. Okay. So this is what the indicator random variable is. Anyways, coming back to the problem over here. Coming back to the problem. So we will define something. What we will define? Let's understand. So what we're trying to see. We are trying to see that whether the idea that like 110th person is being the highest scorer, is it really like dependent upon anything or something like that? Let's check it out. Okay, let's check it out. In fact, we'll show it's not in some sense. So let's understand this. So let's say I j is the indicator random variable is 1 if jth person sets a record, 0 otherwise. Okay, it's telling that ij is 1 if the jth person sets a record and 0 otherwise. Okay, why we are defining this, guys? Because we are interested in the because we are interested in the event. You are interested in the event A is equal to, this is the event A, right? So Shuprabhu was asking, na, this is the event A. We are interested in the event A is equal to AJ say is that jth person sets a record, right, Shuprabhu?
Yes, sir.
So that's why. Oh, is it Shuprabhu or someone else who was asking that question? I think someone else was asking that question. Who was asking that question? Anyways, or maybe it's for Shuprabhu. So that's the idea. Okay. Now what we are interested in. So understand this very carefully. Understand this very carefully. So do you see this aspect that so this is where the symmetry principle comes up due to the IID aspect. Okay. Understand it very carefully. It's a very careful idea. It's telling that we will show this that probability ij is equal to 1. It's actually nothing but 1 by j. It's equally likely. Why this is true? Let's take this case. Let's take 3 cases, 3 ones. Let's take 2 cases. So x1 greater than x2 and x2 greater than x1 can be there. So what is the probability j? I of 2 is equal to 1. Sorry, what is the probability? What was this? Yeah, I of 2 is equal to 1. That means the second height is, the second one is the highest. It's half, right? Because this plus this is equal to half. And these two are equal, right, guys? Did you see this? Did you see this aspect now? Now we will understand this very carefully. Let's see. So, probability x1 greater than all the other cases. That is, probability first person is like not probability first person, probability this one. Okay, this is the alpha. ठीक है. Now let's take probability x2 greater than everything else. This is can you see that this two, since x1 and x2 are IID, this must be also alpha. Can you see this? Since x2 and x2 are x1 and x2 are IID, these are interchangeable, right? These are interchangeable, right? Did you see this, guys? This is the most important aspect. Since these two are IID, these are interchangeable. Did you see this aspect, guys? All of you.
So when can you say two random variables are interchangeable?
When they're IID. So it's like x1 greater than x2. It's like, understand this. x1 greater than x2 is sort of same as x2 greater than x1, right? Is also same as x3 greater than x5. What is the idea? Understand this, that I mean interchangeable in this aspect, they're IID, right? So see, just like x greater than y, it's distributed same as, the probability is same as y greater than x, right? Because they're IID. So they have no relationship among themselves. So the idea is that x and y actually behaving in the same manner. In fact, it's same as probability z greater than z dash for any z and z dash following the same distribution. Did you understand, guys? All of you understood this. This is a very important strategy. This is a very important result, guys. All of you understood this. It's a very interesting idea, right? So what do you get over here? That x1 is the highest, like the x1 jump is the highest among all this j till j point. Is same as x2 is highest among all the j point, because these are IID, they are behaving in the same manner. So x1 greater than all others is same as. So it's a sort of renaming. Understand, it's a renaming. Just understand it's a renaming, okay? It's a renaming. So when they're IID, that's a, if you change it, the inequality sign, it's a renaming of the whole thing. It's called renaming, okay? Like it doesn't matter whether it's a different dress. So that's it. So similarly, it will be probability x3 greater than all the others. It's a renaming. All of them, it's same as last mein jaake xj greater than all others. This is all alpha. Now the sum of all this will be what? J alpha. The right hand side will be what? Probability x1 is highest plus probability x2 is highest plus probability xj is highest. What will be this probability? Can someone tell me? What will be this right hand side probability? Can someone tell me? Tishika, Suryanshi, Suprabhu, Sriteja, Sneha, Proma, Priyansh, Pratiksha, Pallavi, Mansi. Anyone? Can you tell me what is this right hand side? What is it? Nikhil, can you tell me if you're on your live? What is the right hand side, guys? It's very easy. 1. Why it's 1, Pallavi? Please unmute yourself and tell.
These are the only possible means event that can happen. Either x1 will be highest or x2.
Exactly. Either one of them sets a record, always. Right? So it will always, this is the only possibility. These are all the possibilities. These are exhaustive events. So their plus will be 1. That's it. So it will be 1. All of you understood this beautiful strategy, guys. So all of them are equally, this is the most important idea, and that is really, it's one of the most important, the mode of all the questions that, like the strategy of the questions that usually come. All of you understood this. Write a boom in the comments, guys. Do you like this, guys? Okay, perfect. Perfect. Thank you, guys. So this is one of the most important strategy that one can use now. And this is really super interesting. Okay? So therefore we get that what? Alpha is equal to 1. Alpha j is equal to 1. So each one of them equally likely. So therefore we get that probability ij is equal to 1 is 1 by j. So this is what we have got. Okay? Very good. So what's next? What's next? We need to now check. We need to now check that what? here the given thing is what? Here given thing is that here it's told that ij is equal to 1 and ij plus 1 is equal to 1. That both j and j plus 1 are setting the record. Rather, here it's actually equal to I 110 is equal to 1 and I 111 is equal to 1. Okay, this is what the idea is. This is what they're asking for. We have to show whether it's equal to probability ij is equal to 1 or probability I into probability I 110 is equal to 1 into probability I 111 is equal to 1 or not. This is what we have to check. This is what we have to check. Okay, essentially. Whether it's true or not. That's it. Whether it's true or not. So we have found that this is equal to 1 by j, like 1 by 110. This is equal to 1 by 111. So we need to find out what is this. And similarly, this will turn out to be really interesting. Another interesting symmetry property. Okay. So let's find it out. What is probability I of 110 is equal to 1 and I of 111 is equal to 1. Okay? And let's understand this. This means what? This means probability x 111 greater than x 110 greater than all these aspects, all the other rest of the stuff. Okay, guys, this is what is the basic probability you need to find out. This is the basic probability you need to find out, right? Now what you do? Now what you do? So we have to find out this probability. Okay, we have to find out this probability. So how do we do it? How do we do it? If we replace, so what are the full, like, you have to understand, you have to break the entire set of spaces into such greater than categories. So this is meaning what? That there are two greater than. Okay. Yeah, someone is saying something. Oh, Suryan, can you mute yourself? Yeah, it's okay. So perfect. So the idea is that x11 greater than x10. No, koi baat nahi, students. It's totally fine. X11 greater than x10. So we have to sort of make sense in this aspect. You have to distribute the entire sample space so that it's the probability is 1 into this way. Okay. Now understand what are the possibilities. Now understand what are the possibilities. Let's understand this very carefully. What can be the probable possibilities over here? Let's think about it. So क्या हो सकता है? Okay, so understand that this probability, there will be always two greater than. Okay, so it's this probability that x1 greater than x2 is same as probability x1 greater than x3 is same as probability x1 greater than x4 greater than all of them is same as probability any xk greater than xj, right?
So I have a doubt.
Sure, bolo, Sneha.
Sir, isn't it the case which we were considering before, like for alpha, probability x is greater than everything else?
No, probability of alpha देखो सिर्फ एक greater है, एक one greater than all of them. But here there are another condition. One is greater than another, and that is greater than another. Okay. I mean, if you take all the cases, sum of all the cases of just x1 in the beginning, like all x1 in the beginning, all the cases, then that will give to rise probability of x1 greater than this. This is what will all of them sum to give rise to. Did you understand?
Yes.
Yeah. So, but this is a special case. There are two inequalities, like two restrictions, another extra restrictions. Okay. To understand, therefore, all this probability are equal to what? Probability of any xk. Understand this. All this probability is same as, all the probabilities are same. That is how we can write it. It's same as probability xk greater than xj greater than this where k is not equal to j, right? This is equal to all of them equal to alpha, right? Did you understand this, guys? All of them equal to alpha. You're right, Nikhil. You can write, Nikhil. You can also do that. Yeah, you're totally right. It's totally fine. You can also do that actually. Yes. Did you understand this, guys? Did you understand this, guys? That probability xk greater than xj greater than all of them, greater than rest of them, is same for any case. All the values are same because of the symmetry. Because it doesn't matter, since x1 and x2 IID, there is no relationship between them. So you can actually interchange and rename any one or any two of them. You can just replace any two of them. Did you understand, guys, all of you? Yes or no? Yes or no? Bolo. Do you have some doubts in this? Mansi, Polami, Pratiksha. This is a very important part. Priyansh, Proma, Sneha, Sriteja, Shuprabho. Thank you, Suryangshi. Tishika. All of you understood it. Is it a boom stuff? Good. All of you boom? Perfect. Very good. So, perfect. So, these are all equal. So, let's say equal to its beta over here. So, therefore, sum of all of this will be kya hoga? It's 1 because these are all the possible stuff. Sum of all of this is equal to 1 because it's exhaustive. Any two must be greater than. And this must be equal to, what? Beta into what? Can someone tell me what is this beta into what it will be? Beta into what? What was the variable there? How many such cases are there? Can someone tell me? How many such cases are there? Bolo, very quickly. How many such cases are there?
K, sir.
K? Why K? Explain it why.
So it's
What is K?
K to K.
No, we are taking any x and x, any xk and any xj, so that k is not equal to j. All the possible such cases. We are taking any xk and any xj, not j minus 1. There is no j minus 1. A k and j varies from, belongs to 1 to the order 111. So what we are taking? We are taking xk and xj from the set, like the k and j are from the set 1 to the order 111, not 111. 111 was for the previous one, 1 by j. J was 111. Here kya hoga? Not j. So we are taking xk and xj, k and j are. Have you seen this type of idea? So what we are selecting? We are selecting any two indices, right? Such that they are not equal. Selecting two indices, two numbers out of 1 to 111, such that a is not equal to b or k is not equal to j. How many ways of doing that? Perfect. 111 choose 2. Perfect. 111 choose 2. So the 111 choose 2 cases. So it's actually equal to 111 choose 2 times beta. So what do we get over here? But there are certain cases. It's not 111 choose 2. It's 111 into 110. Why? It's permuting actually. Here x1 greater than x2 is different from x2 greater than x1. It's a permutation. It's 111 p2, not choose 2. Okay. Understand the difference? It's not selecting but also permuting. So it's not 111 choose 2. It's 111 p2 into beta. All of you understood this? It's p2, not choose 2. It's very important. Okay. So what we are doing? It's same as 111 into 110 into beta. So we get that beta is equal to 1 by 111 into 110. Okay. That is probability A intersection B. ठीक है. And probability A क्या है? A क्या था? A was 111, 1 by 100, 1 by j, and probability B kya tha? 1 by 110. Okay, so what we get? Probability of A intersection B is equal to probability of A into probability of B. So they are actually independent mathematically. All of you understood this. So the intuition may tell something. In fact, there is an intuition. Actually, intuition wouldn't tell something because see the fact that 110 is the highest doesn't matter. That doesn't actually affect the fact that 111 is the highest. Never. Okay. 110 being the highest doesn't affect the fact 111 is the highest. So that's the basic idea. All of you understood this, guys. It's a very beautiful problem, na? In fact, this type of problem actually is what you expect in the exams also, and this is one of the most basic and most important idea of continuous random variables. Okay, so there is something, not only continuous, I need to idea, but there is something I thought that you should have asked is that you could have asked me that you couldn't take the case, sir, that x11 is equal to, or let's say you couldn't take the case that x3 is equal to x2 greater than x1 comma x5 comma all of them. You didn't take that case. Can you tell me why you didn't take that case? That is also a case, that is also a possible case, right? But why you didn't take that case? Can you tell me just? Can you, so think about it, okay? Think about why you didn't take that case. Any ideas? But this is a possible case, right? But we didn't take that case. Can someone tell me why I didn't take that case? Anyone? So with this idea, I will end the class. But can someone tell me why I did take that case? Any ideas, guys? Why I didn't take that case? It's a very interesting idea. It's a possible case, right? Do you agree it's a possible case, guys? Write yes in the comment if you agree it's a possible case. Do you agree it's a possible case or not? It's a very possible case, right? It's a very possible case. All of you agree it's a possible case? No, that's not true. It can happen. It can surely happen. It's probability 0. Why it's probability 0? It has to do with something called continuous random variables. Why it's probability 0? IIT doesn't follow. Yeah, right, but that is not. No, that is not true. That is not the correct idea of thinking. Exactly, that is true. But how it's like being useful over here? Yeah, height measurements are continuous. It's a continuous random variable. So, but why this value is true? Why this is true? Like why this is equal to 0? It means what? It means that x2 minus x3 is equal to 0 and x2 greater than x1 greater than x2 greater than all of them, right? x2 minus x3 is equal to 0 and x2 greater than all of them, right? Now understand that this is actually, let's say this is positive. Okay, let's say this is greater than 0. If it's greater than 0, okay, when you will learn marginal distribution, when you will learn joint distributions in my future classes, it's going to come after this. You will see that by integrating, by constantly integrating, keeping on integration, the left hand side can come to this, and the right hand side is greater than 0 because it's integrating with positive stuff like positive PDF, right? It's greater than 0 only. Now this is what x2 minus x1. Actually, the idea is x2 minus x3 is a continuous random variable, and x2 minus x, if you consider x is equal to x2 minus x, probability of x is equal to 0 is actually 0. So therefore, this is not true. This should be coming out to be 0, but this is greater than 0 by the mathematical stuff. So this must be equal to 0. Okay, so this is a basic relationship, guys. This is a very, very important idea. And that's why all of this equality cases is actually what we understand to be like it's the idea of the continuous case. Why this is true? It's a really interesting example. All of you understood this, guys, a bit. I mean, I don't know if you have learned joint random variables or not in your college or not. I mean, I'm just giving an idea. It's a much more advanced idea, but the main idea is that x3 minus x2 is a random variable. It's a continuous random variable because x2 and x3 are continuous random variable. Therefore, x2 minus x is a continuous random variable, and therefore, since it's a continuous random variable, it's taking the value 0 is actually 0. That's the idea. Okay, all of you understood this? Any doubts? Any doubts, guys? Thank you, Pawan. Okay, all of you understood this perfectly? Perfect. Okay, if you like this, if you like the ideas we discussed, 2 ideas we discussed in class. One is the symmetry of the IIT random variables, and there is the universality of uniform distribution. So both these 2 ideas are super important for problem solving, guys, and these are really interesting problem solving strategies. So let's wait for some more problem solving to be done on this aspect, and let's solve the mock test together. Okay, all the best, guys, and see you in the next class. I hope you enjoyed it. If you enjoyed it, write a boom in the comments for the last time today. Bye bye, guys. Good night.